Okay, in this video, I'm going to walk you through setting up a project within Vivado. Now, Vivado takes a long time to launch on my Mac. I'm running Vivado on a Parallels installation on the Mac. So the launch takes a while. So I'm going to skip that step. You search for Vivado in this search tool in Windows. Click on the icon and you should arrive at this screen. So we're going to start with the quick start screen. And what you do is you're going to create a project, and it's going to be important to be careful on where you create the project. So create the project, create a new Vivado project, is what it says at the top here. That's good. Let's hit next. And from here, you want to search where you want that project to be created. Okay, so the way I've got this set up is I already had a subfolder for all my logic labs. I put lab 1 here. So this is looking like a good place. Lab 1 project A was the repo that we took from the class, the GitHub Classroom assignment, and put this onto my local computer. Now, the thing I want to emphasize is that you do not want to launch the project from here. That would put the Vivado project within your repo. And so that would go back up to GitHub when you commit, and big files would be stored there, and it takes a long time, and you don't want that to happen. So what you do is you go up a level to the main lab 1 directory. That's the place where you start the project. Okay, so we put select there. Now we have a good location for the project. It's going to name it. I'm fine with the default name of project_1. Okay, so the next thing we'll do is hit next. All right, here, RTL project, where we do not select any sources at this time. Next. Then we're going to look up the Basys 3 boards. So click the boards tab. So there's 2 tabs here. I click on this. I'm not sure if you can see me do that, but I click on that symbol right there. Then I can search. I start to type Basys, and Basys 3 comes up. If you click on that, that's a link. So click over here to the middle where that's highlighted, and then hit next. All right, so I'm feeling pretty good about that. The default board is showing a Basys 3. It's an RTL project named project_1. That's fine. Okay. So we hit finish. Okay, so now I have the project initialized, and I'm ready to start adding files to the project. Okay, so if you remember the pre-lab, you looked at the workflow for Vivado. You have design files, which we called RTL. We have test benches, which are simulation sources, and we have some constraint files. So we're going to add these in. So the first thing I do, I try to do this systematically, where I get into a flow, because you're going to do this a lot of times, and you don't want to make mistakes, because if you make a mistake, it ruins that project and you have to start over. Okay, so hit design sources where that's highlighted, hit the plus button. And now I'm ready to put in the design sources. Okay, so next. And I can hit the add files button or the plus button here, either one. Okay, so when I see that, I see this repo that we took from the classroom assignment and created on the local drive. So I can click into that, and I remember that design files show up in RTL. There's 2 of them here. I'm going to select both of them and hit OK and finish. So now I have design sources into the Vivado project. The next thing I want to do is put the simulation sources in. So I highlight simulation sources and hit the plus button. And the radio button is selected for simulation sources, so I'm feeling good about that. Hit next. And I'm going to add files. Okay, this is looking in the RTL directory. If you remember, we have this set up where test benches, TB for test bench, that's where the simulation sources are. We click on that and we hit OK. So now I've got the simulation sources in. The next thing I need to do is put the constraints in. Okay, so I highlight the constraints folder there and then hit the plus button. It's got the radio button as a double check. We're going to add files. You can do it this way too. Okay, and I'm going to navigate to the constraints folder where I have the one constraint file for this very simple project. Okay, so now I have everything in the project, and we're not really worried about the actual code yet. I'm going to have you do a code completion so that you'll know what to do and see how to edit a file. But this is ready to run a test bench. We have our design put in, and so we can look at this left-hand column that shows what the different steps are. We've added the sources. We don't need this step because we've already made our design, and now we're ready to do simulations. So to get started with the simulation though, you want to make sure you're running the correct simulation file. So experience tells us that when you do this, you have to click here to see which file Vivado read as a simulation source. Now, I'm not sure why this happens, but often it gets the wrapper incorrectly inserted into the simulation sources. It's also in the design sources, but if that's the case, we just want to select the test bench, the thing that was andgate_testbench. This is the test bench file. I know you don't know a lot about this yet, but what you do is you right click and set this as the top. Setting at the top will turn this into boldface, and that says, oh, we're going to run this as the test bench. Okay, so this is all set up to run, and I'm going to hit run simulation, and it's going to take a little while, but it's doing its thing, looking at these design files and this test bench that we've set up within Vivado, and it's going to run this and report a result. Okay, so it's coming up with a screen, and if you look here, this says there's some tabs. This is the test bench that it just ran. Okay, you don't need to know a lot about that yet. And then there's this tab, this is untitled. This is actually a graph of the signals that are involved. You can do this button to scale those, and you can see this runs through the combinations of what we're looking for an AND gate. Okay, so more importantly, this test bench gives you some text output to let you know whether or not you passed the test. Okay, and the way I have this set up, this is a very simple circuit. It's just an AND gate, and so we're testing with the logic A and B. And so I go through here, and the first three conditions it passed, but the last condition it does not. Oh no, it did pass. I see, because I pushed that. I'd already made this correction. So the first time you do this, it's going to turn out this is the wrong answer, right? So let me do this video a little bit backwards because I don't want to start over. Okay, so I'm going to look at the source file here, and I'm going to go to the AND gate, which is right here. And you see I'd made the correction. All right, so let's put something that's wrong in. Let's put OR instead of AND. In Verilog, an OR is a vertical bar. All right, instead of a plus sign is reserved for actual addition. So A or B. All right, I'm going to save this. Okay, so remember A and B was correct. All right, so I'm going to run this simulation again. Okay, so the signals are populating. You can look at them if you want. But more importantly, when I look at the result of the test bench in the screen print, this test failed, and so what we would know then is that we need to redo the logic on the AND gate. Okay, so that's what I intended to happen first, and then we would go back into the source file. So look at sources, go to the AND gate again. All right, and now let's change this back to and this would run correctly at this point. Okay, so you'd rerun the test bench if you wanted. Okay, But I'm going to skip that step because we had just done it, and we're going to go to the next part of the flow for implementing these designs. Okay, so the next step is to do the synthesis. Okay, so we're going to synthesize this. You don't need to know about this step. We'll talk more about it as the course runs through. All right, but we're going to run this synthesis. This takes a while to complete. Okay, I got these upload errors blocking my view here. Okay. You'll know that something's running if you look up at the upper right corner. These steps take a while. That's why you don't want to iterate a lot of times with Vivado, because every time you're looking at 5 to 10 minutes for things to finish up, and that gets pretty tedious. And this is for a simple circuit. Okay, so while we're waiting, I think we can actually open up the schematic capture. So let me show you what I did. I went to RTL analysis. I click on this, and I can look at the schematic capture. Okay, and so while that's still running, I can open this design. Obviously, this also takes a while. Okay, and nice. This lets us see a schematic of what we just captured. Okay, so you can see we have some inputs here. These are going to be switches on your Basys 3 boards, and then the outputs are going to go to some LEDs. You can zoom in here and see what we implemented. Of course, we implemented an AND gate, so it's kind of nice to see the schematic. All right, so this is finishing up with the synthesis. I'll try to edit some of these slow parts out of the video. And this is worse because it's running virtually on my Mac. It'll run faster on the lab computers. Okay, so it looks like it finished that step, and it's brought up the next part of the sequence. So we just follow the logic. It is going down this left-hand side. So you see synthesis completed. Next, go to implementation, which would be this step right here. So we'll just hit OK. Right, again, you can see this happening up in the upper right corner. It's initializing the design for that implementation step. Okay, so finish that step. I'm not sure why this is the default, because the next step here, for our purposes, is to generate a bitstream. This is the file that gets loaded down to the board. So we click OK on this, and it will take, again, a little while to run and create the bitstream. Okay, so the very next step is we can open the hardware manager, and this is what we use to program the boards. Now, what I can't do is show you this on my Mac because I have a different process for programming the boards from a Mac. But on your PC in the lab, you'll just open the target, connect your USB cable, and go through the next step. It's pretty straightforward to then program the board. We'll walk through that during the lab time. From that point, you'd be finished with the workflow, and you've taken the design and you've pushed it all the way down into the board, and you should see it up and running in hardware.